So, welcome back to what will be I think the 7th video of the Capri Twin Turbo series. So, as you may see, this video is a bit different to the last few. This is more sort of working from the DIY office and, yeah, doing a bit of electronics and things that are, well, it's for the Capri, but it's not, you know, part of the Capri right now. So, I know I mentioned in the last video about the control for the brake servo vacuum, and this is what I'm going to do. Thanks to Chris for taking a mick at me on this one. I'm not going for a simple pressure switch. Well, I reckon it'll be about 30 quid, but it's actually about £45, so it's, so as you may know, I'm a bit of a tight brick. So what we're going to do is we're going to use electronics, which are actually going to be a fraction of the price, and we're going to make our own control. It's more complicated, but actually it's going to be a lot more universal and versatile. So we'll see how it goes, and as for Chris, up yours. So yeah, this is a rather sort of budget friendly one, so we're basically going to use a Arduino Nano, they're like £4, a map sensor, which I believe this looks like a knockoff Bosch unit, but they're fairly universal. This is a 3-bar map, nothing fancy, but about £10 worth, so again, buckle. And then what we'll do when we get into the electronic side of this video, we'll grab a logic level MOSFET for the control and a few resistors and a diode, and that's about it really. So nice and simple. But first of all, what I want to do is I want to design a case for it, because obviously this is going to have to sit up near the servo. I don't want to run it all in the car, it's pointless. So we're going to have to build some kind of case for this one here to go in. Sorry about the lighting, I'm kind of trying to work on it, but it's a, yeah, DIY. So this is going to go in some kind of case, and that's what we're going to design now. And then, as you may hear in the background, I've got a 3D printer running, and that's how we're going to make it. So, yeah, we'll crack on with that. I've got some 3D printing at the minute, and we've got Fusion 360 open. So, we're going to crack on with that, and get some designs sorted out. So first of all, let's unbox this now and see what size it is. Tiny, I'm pretty sure. Yep, tiny. So this is going to sit in a case, standing upright, something like that, along with a MOSFET in front of it and a few other bits, so we can keep the case fairly compact. But this here is going to measure somewhere around the region of, say about 50mm by 50 by 20, and we're going to want the case to be allowing for a MOSFET and such, and a bit more space, probably 15, so sort of thingy's going to be 50, what did I say again, it was 20 on the width, and we want about 15 on the depth inside, somewhere around that sort of mark. And I want it to sit upright in the case, so case around it, have the entry at the bottom here as a removable lid, so the top's all one silk piece, and this will slide up in to the bottom, and connections that will come out the bottom here, so it'll keep it a bit more sealed, and maybe some mounting tabs on here to fix it up in behind the radiator panel. So something like that. We'll jump into Fusion 360 now and start playing around and see what happens with that. Right, so we're in Fusion 360 right now. Basically, I am no expert at this. I'm still learning. I haven't really had much time to learn yet, but I should be able to get by and get the sort of final product we want. It's quite simple. So, to start off with, we're going to create a sketch. And now, sort of dimensional wise, I was looking at having a box around about the 20 by 15 internal diameter. If we go for quite thick walls, because I want this to be quite sturdy and we want some room for play, so maybe if we went with a 28 by 23-ish. So we'll start a rectangle, And we'll go 23 by 28, something like that. That'll be our outside sort of shape. Yeah, I'm still working on this. And then we want to go about 60. Yeah, if we got a board that's 50 high, we want to go about 60 up to be safe. So if we make that into a 3D object now and extrude it up 60mm. Oh. That now gives us this 3D object. And if we want to create a hole, yeah, I'm still working on this. Yeah. Maybe if we go for a 3mm wall, as we went 28, that gives us an extra few mils spare. Better to be safe, and that gives us 2.5. So we've got a box that will slide on over top. That's pretty simple. Now what we could do with is some tabs on the side. So basically I'm going to fast forward this design now. Else the video is going to be forever long. But I'll keep recording, fast forward this, and come back when we got a few bits to show off. Right, so here's the design I come up with after a bit of faffing around. So from the outside, it's a simple little box you can bolt in. So that'll bolt into the Capri. And then as a snug fit on the base here, what we've actually got, if I touch that one, you've got this little base here, sits up in quite tight. I can put a bit of silicone around it to seal it off. Hole for the cables to go off. And then this board at the back here is for the Arduino to be hot glued onto. So that will sit in there nice and tidy out of the way. Keep it sturdy and stop things floating around too much. So that's that. Body back on it. Nice and simple. Yeah, so what we can do is just move the body on off. So if you think about the other way around, that's just going to slot onto that. Nice and tidy. Done. Simple. Nothing too fancy, but should do the job just perfect to keep the Arduino safe and dry, and then removable in the future for work. Right, so with the models made, I'm now in Cura. So this is the software used to basically turn the models we've exported from Fusion 360 into code for the printer to print from. So I've got two items here I want to print. I'm going to print them both at the same time, so I'm going to keep them away from each other, just to ensure the printer head doesn't make any contact with them at any point. So something like that. We're going to set them to print separately. Print them one at a time. And now we also want to potentially add some supports. We're going to have a go a minute and see what. So we have some support. We don't want much support. So we'll try that and see what that looks like. Let's just see how many supports we've got there. Only because the top layer here on the item, it's so I'll configure my bridging settings properly, but that's probably too much support. Let's keep it support density 10%, so line count 1. Let's keep that like 3 mil away. On this, we'll try and ignore any support interface. We also don't want it to be anywhere near 0.08 resolution. 0.2 would be more than adequate. 0.4 mil wall thickness. Yep, line count top bottom thickness. Let's make it a bit thicker. Lines. 4% infill, yes, fine. Temperature wise, I'm trying out some Sunlu PLA plus filament this time, so it's recommended as printed at higher temperatures, so this is guesstimate, a bit of trial and error. So we'll rack up 210 degrees. Keep that the same, cooling's on, supports on. Let's re-slice that a minute and see what happens. Yeah, it looks a bit better there. Only a bit of support just in case. So perfect, we'll get these printed and see what they come out like. Right, so we're ready to print the case off right now. So I'm in Octoprint, which is my interface I use between the printer and the computer. It's just easier than the traditional SD card method. So what I'm going to do is I'm going to load it up in. We'll upload the new file. So it's in there, and it's cover and base. This one here. We'll load it into the printer. He says. There you go. We'll load it into printer. There it is, ready to go. So it recommends that it's going to take about 2 hours at them particular settings to print it. So, and it's only going to use about 8 meters of filament, 23 grams. So not too much. So I'm going to hit the print button and we'll go off to the print and see what happens. So over at the printer, it's heating up and getting ready to go. So I'll set a time lapse up and show you what happens with it. So, sorry I didn't film me building the electronics, just forgot the GoPro and then, yeah, I just had to get it done. But, basically, here's the electronics. So there's the map sensor, temporarily connected up to the map sensor cable, and then the Arduino Nano and a little MOSFET in there just to control it, and the case of course. So basically what this does, I don't know if you can actually read the code or not, no idea, we'll see. Basically what it does is it takes the map sensor readings, and then if, I'm going to change this a minute, if the readings are above, this is absolute pressure, so they're above 500 millibars, so if the VAC's getting down to sort of below minus 7 psi, you can come back to standard air pressure, then it'll kick the vacuum pump on. So then it will charge for what I've got set for 10 seconds, so it'll put the pump on for 10 seconds, and then continue on, and it'll just keep doing that basically. So yeah, we'll get this one installed in a minute and see how well it works. Right, so there we have the Bosch map sensor. So that's fitted up there with the vacuum takeoff from the plumbing. So that's all done in it. I haven't yet mounted the Arduino and the controller bits up here yet. I'm going to see if it works, program it first, then mount it. So we'll crack on with that in a minute and get some more bits connected. So, due to some GoPro errors, you'll notice this footage, the audio is gone. So yeah, I've already lost a few other clips, so basically this is the new outro. Yeah, not great, but shit happens, I'm still learning. So, anyway, pretend the engine's running, and I'm saying some stuff about the radiator flush, it's all gone successful, so great. But yeah, if you happen to enjoy the content, and you want to see more, maybe drop the video a like, subscribe, and leave me a comment and tell me what you think. Until next time, yeah, see you again.